InfoPlus traffic study for the heritage Nortel and Avaya platforms have been the benchmark for the industry for the past 15 years. Consultative, graphic, and analytical, our traffic studies surpass the data dump approach and instead focus on delivering the necessary information required by communications professionals to manage their systems. But as communication technologies continue to evolve, so too must our traffic reports and tools. As a standard feature of the InfoPlus traffic study, the usage of each trunk group is analyzed and converted into a measurement of the bandwidth required to handle that traffic on a voice-over-IP trunking facility. This provides an accurate pre-engineering assessment to aid the migration of current TDM facilities to IP trunking, or a measurement of the bandwidth currently utilized for existing IP trunking facilities. However, to maximize the analysis, InfoPlus has developed an online aggregate bandwidth tool that allows you to dynamically combine the usage of multiple facilities and alter the variables that affect the bandwidth consumption on a shared data network. Whatever the site-specific application you might have, you can count on the InfoPlus traffic study with IP trunking analysis and the dynamic traffic aggregation tool to return the most accurate results possible based on the actual measured usage. Let's take a closer look at how easy it is to use the InfoPlus Aggregate Bandwidth tool and how it will provide incredibly valuable information during your network design and monitoring process. The tool is comprised of several distinct regions. When you first load the application, the main window region provides instructions for you to get started, along with an explanation of the rest of the application's interface. When you scroll over one of the defined terms in blue, the corresponding region will flash, highlighting the part of the user interface being referred to. The Aggregate Sources section is where you select the sources of traffic that will be combined to calculate the total bandwidth consumed. It is comprised of two different options: trunk groups and route patterns. Here, you can select which trunk groups to include in the analysis by simply clicking on the box to the left of each trunk group. Additionally, each trunk group has a slider that you can use to alter the percentages of the usage that is included in the sum. For example, if you know that the Chicago trunk group includes both long-distance calls to the Chicago area as well as calls to your remote branch office located in Chicago, you might want to estimate the amount of usage this branch represents as on-net traffic when transitioned to voice over IP. You simply slide the selector left to the percentage desired. To quickly and easily find the trunk groups or route patterns you wish to include in the analysis, you can sort the list by name or number as necessary. Also, you can clear the entire selection by clicking the Deselect All button when you're ready to start a new analysis. These options come in handy when there are a large number of trunk groups and route patterns programmed in the system. In that case, it may be quicker to use the Select All button and then eliminate those trunk groups and route patterns you don't want to include in a particular analysis. Once you've identified the sources of voice usage you wish to analyze, click on the Generate Analysis button. The application will combine and overlay the usage from each of the selected sources to determine the total activity this traffic would contribute to a shared data facility. Here, you can see that the tool has returned both concurrent connection information as well as the equivalent voice over IP bandwidth for the measured traffic. The bandwidth information returned can be divided into three distinct sections. First, the information here on the upper left-hand section gives you data regarding the busiest hour experienced during the study period, as shown here. Based on traffic engineering statistical calculations and the usage experienced during the busiest hour, the application returns the number of concurrent connections needed to satisfy a 1 in 10% blocking probability. Two grades of service are provided, addressing whether or not you have fallback routes programmed to handle the excessive usage that exceeds the available bandwidth. If there are fallback routes, it's recommended to use the P.10% grade of service as a guideline to reduce the expense of the data facility. These concurrent connections are then translated into theoretical peak bandwidth requirements using a calculation based on the specific codec, sample rate, network overhead, and voice activation detection options you chose for the analysis. Just below the peak requirements is the chart that defines the average amount of bandwidth required over the same busiest hour. If you took a sample at any moment during the busiest hour, this is the best estimate of the instantaneous bandwidth being utilized. The second section here on the right-hand side looks at the traffic over the entire length of the study, not just the single busiest hour. In fact, this information comes from selecting the busiest hours of each day during the analysis period, including the absolute busiest hour, and calculates the average from this data. The average busy hour calculations will always be less than the maximum busy hour numbers and will be more representative of the typical busy hour in very peaky traffic environments. Finally, the graph at the bottom of the page shows an average of all hourly data over the study period, where the blue bars display the peak bandwidth requirement and the red line shows the average, following the same methods used in the top and middle section of the page, respectively. Once you've identified the trunk groups and route patterns to evaluate, the tool provides you with the flexibility to adjust the analysis using several variables. In the codec section here, for example, you might want to evaluate the effect of using codecs other than the default G.711. Simply open the codec window, select any one of the available options, and update the analysis. For example, using a G.729 codec will use less bandwidth than the G.711, but at the expense of a reduced voice quality. Take note of the original average busy hour bandwidth using the G.711 codec. Changing to a G.729 codec will significantly reduce the required bandwidth. You also have the option to change the codec sample size and select the appropriate network type. Each type of network has a different amount of layer 2 overhead per transmitted packet, and these differences are taken into account during the analysis, providing highly accurate results. To explore the effects of enabling voice activation detection in the system, check the VAD enabled box here. With voice activation detection enabled, no data packets are transmitted at all during the silent portions of conversations, reducing bandwidth utilization by as much as 35%. When designing networks to carry voice over IP traffic, it's important to consider any changes in traffic usage you might expect in the future. For example, you may know that the company will be adding personnel in the future, and therefore, the usage will increase. Here, in the overall growth section of the interface, you can include the forecast on a percentage basis. Let's say that within the next year, you're expecting an increase in usage of 20%. Simply slide the growth selector to the plus 20% and update the analysis. Similarly, you may know that the company will be downsizing or moving personnel to another location, and therefore the traffic will be decreasing by some percentage. Being able to consider these various scenarios improves both the IT professional and management's ability to accurately engineer and properly size data facilities, minimizing costs. The application allows you to analyze bandwidth utilization by route patterns, providing an even more complex analysis by call type. There's many occasions where calls are made between locations using the public switch telephone network. In order to isolate the traffic that will be on network after a migration to IP trunking, we need to evaluate the appropriate route patterns programmed in the system, as the trunk group's usage consists of both on and off-net traffic. Select the Route Patterns tab. Enable the route patterns you wish to include in the aggregate bandwidth calculation and update the analysis. Just like the trunk groups, you can further tailor the route pattern analysis using the same variables discussed previously. In exploring these what-if scenarios, you may want to save or print each setup for comparison purposes. Once you've generated an analysis, click on the Print Version button. The resulting page will include the full analysis results along with the setting of each parameter and a list of the trunk groups and route patterns included, suitably formatted for printing or saving to a local file for review. One of the most important factors in designing voice over IP networks is making sure there's sufficient bandwidth to handle additional voice traffic, particularly during the busiest periods. A common practice in the design phase is to over-engineer the network capacity to ensure voice quality of service objectives are met. However, this strategy potentially adds additional costs to the project that may not be necessary and diminishes the return on investment, often crucial to such plans. The InfoPlus traffic study with IP trunking analysis, together with the aggregate bandwidth tool, were designed to eliminate the guesswork by providing accurate information based on real traffic data, with the flexibility to fine-tune the analysis depending upon the unique application.